So here we are. We're going to try to work through a weight and balance problem that's on the written exam. We have a sample problem here. Christian's brought in for us. It says, refer to figure 33, 34, 35, and 30. Oh, no, I'm sorry. Refer to figure 33 and 34 on pages 35 and 36. So our page numbers are off, but we're going to be looking at figure 33 and 34. So just to frame us up here, we got figure 33 and 34. So figure 33 and 34, which again, doesn't look like it really adds up too much because we have figure 34 is showing the graph. Figure 33 is actually continued. So really what it looks like is probably figure 32 and figure 33, but maybe the FAA has updated the figures since this question was written. So as the person who's done this before, I'm thinking that the question should actually tell us to reference figure 32 and figure 33. I think that they've redone this testing supplement since this question was written. So anyway, I think that we're looking at the fact that what effect does a 35-gallon fuel burn from the main tanks have on the weight and balance if the airplane did weigh 2,890 pounds and the mom divided by 100, the moment, was 2,452 at takeoff. So the whole idea is that we have to do weight and balance math. There's only two equations for weight and balance. WAM, weight times arm equals moment. And then mom's over weight. So moments divided by weight equals arm, which would be the center of gravity location. What's going on right now is that there are different ways to do math for different pilots. And the idea is that when we start to do weight and balance math and we get moment, M-O-M-E-N-T, moment, sometimes moment can be a very large number. So, you know, maybe just a quick review. Weight times arm equals moment. Weight is pounds, arm is inches, moment is pound inches. So the idea, what is moment? Why do we care about moment to begin with? Moment is a way of measuring force. Moment is a measurement of force. It's really a way to quantify, it's a way to put numbers to the concept of leverage. So the idea is that everybody understands the concept of leverage. If you had a longer arm, if you had a longer lever, then you would apply force, but your force would be more felt. You would get more moment. You would have more leverage. So moment, if you start to get big moment numbers, then there's a lot of force. And if you have an extra long arm, you're going to create extra force, extra moment. If you have a shorter arm, even though you have the same amount of force, I said it wrong. If you had a shorter arm, you might have the same weight, but it would not create as much force. So really what's going on is we're doing math. We're doing all this math to really explain the concept of leverage. Okay, so now that we have an understanding of what we're talking about, it's the fact that this airplane in question has multiple fuel tanks. So if we look at our picture of graphs and figures, here it should be. Let's zoom in so we can see what we're looking at. We can see that there are multiple fuel cells. There are multiple fuel tanks on this aircraft. So for example, this aircraft in question could have a main fuel tank, and that main fuel tank would have an arm of 75 inches. This same aircraft has auxiliary fuel tanks. The auxiliary fuel tanks have an arm location of 94 inches. So depending on where we burn the fuel from, whether we burn it from the main tanks, which has an arm of 75 inches, or whether we burn from the auxiliary tanks, which would have an arm of 94 inches, then that's going to affect the arm, the amount of leverage, the amount of force change that we see when we lose that fuel. So if we was burning fuel from the auxiliary tanks, then we would have a greater moment change. There would be a greater force change because there's a longer arm. It's a longer lever arm. When we burn the fuel from the main tanks, 75 inches, we'll see a smaller amount of moment change because it's a shorter arm, even though fuel weighs the same regardless. Okay, so now that we're framing the idea of what we're talking about, let's analyze the question. What effect does a 35-gallon fuel burn from the main tanks have on weight and balance? Okay, well, let's have some knowns and some unknowns. I'm going to hit the annotate button. Are you seeing my screen? You're not. I got to hit the button.
No, I'm not. I'm seeing you.
I'm so sorry.
No, you're fine.
So I just showed you a lot of that stuff with my mouse. Just very, really quick review. I was showing you while I was doing it that if you're using the main tanks, it's an arm of 75 inches. And then if you're using the auxiliary tanks, the arm is 94 inches. And what you're gonna find in weight and balance, when you do a weight times an arm, these numbers become very large. So when you analyze moment, you could find yourself using very large numbers. There are different people in the world. Some people like to have big numbers and just keep the number very big and very large. Some people like to scale the number down. So when you see this moment divide by 100, they're scaling down the number by 2 decimal places. So by putting on the unit of measurement, moment divided by 100, they're explaining to you that there are 2 additional decimal places that are not being accounted for. So that way they can give you smaller numbers, like 22 and 45. Well, those numbers are actually 2200 or 4500. They are larger numbers, but they think the FAA thinks pilots, people who do weight and balance math, some people like to use scaled down numbers that are missing decimal places, so that way the number doesn't appear too large. Personally, I would rather just go ahead and use the full big large number and then not have to do any scaling up and down. It really doesn't matter, just as long as you keep your math straight and you keep your decimals straight. I tell you, if we were doing weight and balance for Boeing 747, how big and how heavy is that airplane? Yeah, we're gonna have to scale down some decimal places because it's gonna be too big of a number. But for us in this, airplane in question for private pilot, we're probably not gonna have too big of an issue either way. Goodness. So what have we learned? We have learned that we are trying to answer the question, and one of the big things we need to analyze is what is the effect of a 35-gallon fuel burn? What do you think, Christian? How much does fuel weigh?
It's 6 pounds. So
okay, so fuel weighs 6 pounds a gallon. So there are some math problems on this written exam where you will have to do that math. You will have to figure out 35 gallons times 6 to figure out how many pounds that would be. And if you want to do that math, we can. What you're learning, though, in this chart is that they've already done the math for you. So you can see that in this figure looks so complicated because there's numbers everywhere, but it's really just the fact that they've done a lot of math for you, and you look at the chart to figure out what the math answer is. So in this example, here's your gallons from the main tanks, and you said you're going to burn 35 gallons. Well, they're telling you right there, that's 210 pounds worth of weight, which is what the same thing you did when you reached for your calculator and you typed 35 times 6.
Nice.
And then the moment is 158, but that's moment divided by 100. So that number is truly 15800. 15,800. And it's really, they're just doing the math for you in this figure. Weight times arm equals moment. The weight is 210. The arm is 75 inches. 210 pounds times 75 inches is going to give you a moment of 15,800 pound inches. That's the force. That's the leverage. That's the force that's change that we expect to see when we deal with 35 gallons, 210 pounds with an arm length of 75 inches. We're going to see a change in force moment of 15,800, or you call it 158 divided by 100. Have I lost you? Are you with me?
No, I'm tracking.
Okay, so I'm going to keep trucking then. Now that we understand what we're looking at, it says, what effect does this 35-gallon fuel burn from the main tanks have on the weight and balance if the airplane had weighed 2890 pounds and the moment divided by 100 was 2452 at takeoff? So weight and balance math is, it's really simple. I know it's complicated, but just tell yourself it's simple and it'll be more simple. Just for my sake, I'm going to write down these numbers on my little scratch piece of paper in front of me so I don't have to flip back and forth so much.
Right.
And so I have 2890 pounds, and I have MOM divided by 100 to be 2452, and this is at takeoff. So, I mean, you know, if I hit the button here, you'll kind of see what I'm working with here. And it's just really, really simple thing that I just wrote down for myself. You know, 2890 pounds for takeoff. My moment divided by 100 was 2452. So now that I have that information handy, I'm going to go and check out the, and try to remember the question. What effect does fuel burn have on weight and balance? Okay, so let's take a look at that figure. Here's our figure, and I'm going to use my text type tool to start setting up some math for us. I hit annotate, I hit text, I come over here, we got plenty of space over here in the margin. So on takeoff, remember it's weight times arm equals moment. That's kind of the big conversation. So when we took off, the airplane weighed 2,890 pounds. It had an arm location or a center of gravity location. And if we wanted to do math, we could figure that out, but we don't necessarily have to. But we know that the moment on takeoff was 2452. And we have to make a decision right now that's going to affect the rest of our math. Are we going to use the full decimal places and add 2 zeros, or are we going to keep it smaller numbers without the zeros? Personally, I like to add my zeros and just keep it as a big number, but you can do it either way. So for today's sake, I'm going to add the 2 zeros right now. Bam. I just added my 2 zeros, and we just have to remember to continue using our same format through the rest of the math. So if I let's label things. That's pound, inches, and that would be our moment, the amount of force that's being put down on the center of gravity, wherever the center of gravity location is, at takeoff. Okay, cool. So now that we got that established, here's some really simple math, okay? At any time, center of gravity is simply mom's over weight. Moment divided by weight. So if there's any change, simply plus or minus moment divided by plus minus weight. So we know that there's going to be a change. We're going to have some change. We're going to burn some fuel. Okay, cool, awesome. So let's burn fuel. We're going to burn 35 gallons, which weighs 6 pounds a gallon. So we're going to burn, and they already did the math for us, 210 pounds. Okay. Now we would know that 210 pounds times arm, because remember the very top, let's just label it. Let's make it really simple for everybody. Weight times arm equals moment. So we know the weight that's going to change is 210 pounds. We know the arm location from the main tank. Wish I could undo that. Mouse. Can I click my thing? I'd really like to keep typing there. What a bummer.
What happened? Did you just click
There
out
it
or
is.
something?
It's gonna work.
Nice.
It's gonna work. Damn it. Select it. So I can select this, but I want to keep typing in there. Oh yes, I'm in. Okay. So we know our arm location is 75 inches. So if we did the math, that would give us a moment change. And again, it's already right here, but I just can't click or I'll screw it up. It says 158. Do you see that?
Yes, sir.
So it's going to be 158. But wait a minute, we're using the extra 2 decimal zeros today. And that'll be our pound inches moment change. Have I lost you yet? Are you still with me?
Yes, sir. I'm just thinking about it.
Okay, so here's the big kicker. We've said all this to actually do the real problem now. Okay, so we started our day at 2,890 pounds. Subtraction, we just burnt how much weight? 210 pounds. So now, after we burned that fuel, just use the calculator. I know I can look at it and it's gonna be, what, 2,780? Just write it, 2,780 pounds. And just to check myself, I'll type it into the calculator because sometimes, you know, I catch myself doing bad math. Subtract 210, I get 26. Yep, see, I did bad math. Gosh. 2,680. That's usually the biggest problem right there. Pilots do bad math. It's usually the biggest problem. Use the calculator. Okay, so where am I at? This is now my weight after the fuel burn. Okay, well, my moment when I took off was 245, 200 pound-inches. And throughout that fuel burn, I'm going to see a moment change of 15,800 pound-inches. So the moment after fuel burn is going, just use the calculator, 245,200, subtraction sign, 15800. Gets to be 229, 400. And that will be my pound inches moment after the fuel burn. Is this good? Is this bad? Is this
Yeah,
ugly?
no, this is perfect.
Okay, so there's just a small bit more math I can do. I'm probably actually doing way more math than necessary for this problem, but I'm just trying to explain to you how to do all this math in general. So the only thing we really haven't done is figured out center of gravity location. So let's analyze. Let's look at CG location. Okay, so at any time, CG is simply moment divided by weight equals center of gravity location, which really is the same thing as saying arm. So let's talk about takeoff. On takeoff, my moment was 245, 200 divide by 2890. And I should label these things. That helps people out. So 245, 200 was pound inches. That was a moment. And then there's our division symbol because we're going to divide by 2890 pounds. And so I get an equal sign to find my CG location. Just type them into the calculator. 245,200 divide sign 2890. So I get a center of gravity location, a CG location arm of 84.844 inches aft of the datum. If you had done the scale down of the 2 zeros for moment earlier in the problem, then you'd have to rescale the 2 zeros back here during this step. But you'd figure it out because you'd be like 0.00844. You'd have to figure that out, you know, or 0.84. Okay, so that was our center of gravity location on takeoff. Okay, well, what was our CG after fuel burn? So now let's look at CG location after fuel burn. Okay, so after the fuel burn, again, center of gravity is always simple. It's moms over weight. So moment divide by weight. Okay, well, our moment after the fuel burn, somewhere on this chicken scratch, we're going to find it. So here's my moment after. Oh, wow, it just made it really big. That's not handy. It's not bad. Let's just move over to the right side, maybe. Something's, man, I wish I knew how that happened. Let's just come over here. I want to type a new one. Oh, now it's working. Okay, let that one be. Let's just type a new one over here. We're so close. I appreciate your patience with me.
No, you're fine, sir.
Okay, so now let's look at CG location after fuel burn. All right, we got ourselves a nice window to work with.
And that would tell you whether it moved left or right, correct?
Left or right, it should move forward or aft.
Forward or aft, yeah.
And I'm telling you, it's going to move forward because every airplane that I know of, center of gravity moves forward as we burn fuel. Because like our datum is usually something forward, like the firewall or the nose or the leading edge of the tire, some imaginary point 100 inches forward of the leading edge of the wing. So as we lose weight from the ass end of the airplane, the center of gravity usually moves forward towards the nose. So let's take a look at the CG location after fuel burn. Okay, I'm glad you asked. So at any time, CG location is simply moment divided by weight. So after the fuel burn, so I'm looking over here. Oh, you're not even, you're seeing my screen. Okay, good.
Yeah, I am. I'm taking notes.
It says, so I need to find my words to talk about I need to find moment after fuel burn over there. Pounds weight after fuel burn, pound inches moment after fuel burn. It's in the middle. It says that it was 229, 400 pound inches, and that was my moment after the fuel burn. So at any time, center of gravity is simply mom divided by weight. So what was my weight after the fuel burn? I see it over there. It says 2780 pounds. 2780 pounds. That was my weight after the fuel burn, after I burned 35 gallons. So equals, and again, just type it in the calculator, save yourself this trouble of screwing up the math, 229,400, division sign, 2780. I get an answer of 82.517. That's plenty. So that would be my CG location arm. And that's after the fuel burn. At this point, I think I've literally done every type of center of gravity, weight and balance math I can with the information that they've given me. Nice. I've done it all. There's no other math left to do. So all this information in front of me should give me enough knowledge to be able to select A, B, or C. If I was taking a time test, I wouldn't take all the time to do this. I'm doing this to kind of show you. And if I was doing a time test, I would be way more precise about what math is necessary and what's not necessary. But with us, I'm just trying to introduce you to all the different types that could be associated with it. Now, if I'm guessing, if I remember the question correctly, I think it said, what's the effect? So what's the effect? I think that we're going to see the center of gravity move forward. So at takeoff, our center of gravity was basically 84.8 inches. And then after we burned fuel, it says 82.5. So basically, I think the center of gravity moves forward about 2 inches.
All right, I get it.
Let's see if that's one of the answers or if they're asking for something else. I can't even remember the question anymore. So what I need to do is I need to get back to my mouse. And I go over here and I click the question. Oh, it's a little more tricky. Okay, so now what it says is, what's the effect? Am I still within limits? Am I out of limits? Is it aft of limits? Is it forward of limits? Okay, so this particular question is gonna be an answer of scrolling down to the next figure. Okay, so I think all my notes will stay here on the screen, and I'm gonna scroll down to the next figure. Okay, so here's the next figure. This figure's interesting. So typically we would do it all with math, but they're trying to help you out by publishing a lot of the information right here on the chart. So in this example, they're giving us different weights. So we find our particular weight, and they cut out the middle math. They don't make you do the middle math of center of gravity location. Instead, they tell you what the minimum moment would be. They tell you what the maximum moment would be. So if you have a moment that doesn't fall in that range, then you are out of center of gravity limits without doing extra math. Personally, I'm the person that just does the math, but we'll use the chart for this problem. So here we are. What are we using? We're using information about after the fuel burn. So here's the information over here about after the fuel burn. So after the fuel burn, we found a weight to be 2,780 pounds. So here's 2,780 pounds. The minimum moment we could have is 2232. We have 2294. Because remember, we have the 2 extra zeros on ours.
Yes, sir.
So 2294, the minimum moment for our weight was 2780. Here's our weight, 2780. I wonder if I can highlight this. I don't think it'll screw us up. So this, gosh. Yeah, I don't know if that's helpful or not.
Yeah, I can see a lot better actually.
Okay, so the minimum moment is 2238. That would mean like if the center of gravity, how far forward could the center of gravity go? Be 2 minimum. 2232. We got 2294. So we have a number that's aft that's bigger than the minimum, which is good. Our center of gravity is not too far forward. Now let's analyze the next number. The maximum moment. Here it talks about the word maximum at the top. The maximum is 2366. We have 2294. The maximum is 29. Damn it, I said it wrong. 2366. We have 2294. So the maximum is 2366. We have 2294. What do you think, Captain? Are we too far aft or are we within?
We would be too far aft? Or no,
No.
Too forward. Far forward.
No, we're in it. We're nailing it. We're doing a great job. Look, the minimum number would have to be, you cannot have a number smaller, minimum. You cannot have a number smaller than 2232. The maximum is 2366. You cannot have a number bigger than 2366. What's our number? 2294. Our moment, our force is 2294.
Oh, I didn't catch that part right there.
So we are within the limits. Nice. If we would have gotten a number that's bigger than 2366, then our center of gravity would end up being too far aft. If we would have gotten a number that's smaller than 2232, our center of gravity would be too far forward. We got a number of 2294, which means our moment is within the limits.
That works.
I know it's stupid. It's a lot of math. I promise I didn't create this problem. You know, I think that it's a little bit more. So let's go see what some of these answers might be before we critique it too much. So we have answer choice at A. We've lost 210 pounds and the aircraft is still within limits. That sounds pretty tempting. B, 210 pounds more. What? How do we gain weight? We burned fuel. We lost weight. I don't like answer choice B. C, 210 pounds less and the aircraft is aft of limits. They said that's the correct answer, but I don't know if that's what I got. D, 210 pounds less and the aircraft is forward of limits. I mean, I'd be really tempted to click A. Maybe I screwed something up. Let's see what they say about C. They say the correct answer is C. They say 210 pounds less and the aircraft is aft limits. First, calculate the fuel burn of 35 gallons at 6 pounds per gallon, 210 pounds less. We figured that. Look at the figure and the numbers. Find 35 gallons, 210 pounds, which changes CG by 158 according to the chart. And that's what I have here. See 158?
Yeah.
See, they say it's going to change the CG. No, it changes the moment. It changes the moment. So whoever wrote this also, you know, may not be the perfect either. Subtract the weight from the original weight, 2890 minus 210 to get 2680. And we did that. We got that. See, I got 2780. Did I do it wrong? 210 pounds minus, ooh, gosh, maybe I screwed up math way early in this problem. 2890 subtract 210 should be 26. Yeah, so it looks like I might have done a little bit of bad math there. Let's see what keeps happening. And then subtract the moment of 158 from the original moment of 2452. Now figure 30. Okay, so I've screwed us up and I know how to fix it. I'm so sorry to waste your time and screw things up.
No, you're fine.
let's make it right. So over here, this is the step where I screwed up. And I double click, now I'm typing. So 2890 pounds minus 210. So I'm just gonna type it into the calculator, 2890, subtract sign, 210, equal sign, 2680. So click 2680, that's our weight after the fuel burn. So here we found pound inches, that's the same. Now let's look at the center of gravity location. Takeoff, that's the same. Now let's look at the CG location after the fuel burn. So now we're over here. So here's where I screwed up the math. It says 2780 negative, subtraction sign. We should have had 2680. So now let's do the math. 229400 divide sign 2680 equal sign 85.597. Okay, now when I look at, oh, I'm on the annotate tool, I hit mouse. Now when I look at the chart, we have to analyze the correct weight. We were analyzing the incorrect weight. So when we analyze the weight of 2680, here's 2680 right here. The minimum moment would be 2123. We got a moment of 2294. So we're bigger than the minimum. That's good. The maximum is 2287. We have 2294. So our moment is too big, too far aft. So I screwed us up and I did bad math way back yonder, way back when. And since then we've corrected it. Just one more time. These are our numbers right here at the very end after we did all this math. And it tells us that our weight after that fuel burn is going to be 2680. So here's our weight, 2680 in the chart. Our moment at that time is going to be 2294 divided by 100. So we have the smallest number our moment could be is 2123. The biggest number our moment could be 2287. We are bigger than 2287, 2294. We're too big. So we are aft. So I am thinking that this question, C, is the better choice. We did lose 210 pounds less, but unfortunately, the aircraft is now aft of limits.
That makes a lot of sense.
I'm sorry to screw you up with some math issues, but it's going to happen. You know, people have bad math issues. You know, it's a learning process. I hope it's helpful. Gosh, what are your thoughts, Captain?
No, so far I like it, and I like that. Honestly, I do like that we screwed up because it kind of puts into perspective of what needs to be done. So that's honestly, if I get things right on the first time, it kind of just gets put in the back of my head, and I don't really worry about it anymore. But if I get things wrong, I tend to focus more time on it. So I like this. I like that we kind of messed up a little bit and we figured it out. So this is going to stick more with me when I see this question again.
And the other thing that I really encourage you to do is take the time to label everything clearly.
Yeah.
So like the fact that I've sat and made all these labels throughout the whole process, I was able to go back and just plug and play and figure it out correctly, even though I did make a mistake. Whereas if I didn't clearly label every step, it'd be like a nightmare to start all over again to try to figure it out.
Yeah, that makes sense.
So I don't know, man. This is me walking through some weight and balance. There are 3 types of questions on the day of the written exam. When you take the test, it's standardized testing. So, I mean, the same ABC multiple guess for, you know, this question, that question, they're all worth the same. But this problem is going to be way more difficult. This problem is going to be way more math. It's going to be way more time consuming. You would be foolish to just go ahead and start tack on that problem when it came up. You're going to be way better off if you save that problem for the end. So if the countdown clock is ticking, you don't, you know, burn up all your time and all your brain power, you know, doing an hour worth of math that's worth the same 2 points as every other question.
That works. Awesome. Well, I greatly appreciate it. I really do. I mean, I could go all day with this stuff, but I got what's his name coming over. I got Isaac and Alec coming over. We're gonna start
Cool.
going over what's it called? Just our regular check ride stuff since we haven't been really doing any of it. You know, I'm starting to forget a couple things. So we're gonna touch up on that. But I greatly appreciate it, sir. Thank you for your time.
Well, thank you so much for reaching out, and I hope this is helpful, and I hope that you have a great day. Get some sunshine.
Will do. Thank you, sir. Have a go.
Hey, thank
Bye.
you.